All right, so now we have substitution with powers. So we have x equals t squared and y equals t cubed. Let's look at Desmos just to cheat. So for my x coordinate, I plugged in t squared. For my y coordinate, I plugged in t cubed. And now I have just negative 20 to 20 to give me enough room. And this is my graph. So now when I push play, that is the direction that we should be getting. So our graph, when we do our substitution, should look just like this blue one. Again, all the parameter of t is doing is giving us motion along our track. So when we do our graph, we're going to do our substitution to give us our track. And the t will give us the direction. I just like watching it. Okay. So when you come over here to substitute, we could either solve for t squared and give us square root of x, or we could do t cubed. And t cubed is nicer because when you take the square root, we're not getting that plus or minus. So that is where I would go for first. So when I do my cube root, I get a nice clean t equals cube root of y. 100%. We know we're good. So x equals, and then we go, oops, let's plug it in slowly. This is t squared. So x would equal parentheses squared, cube root of y. So we have x equals y to the 2/3. So that is our graph that we are graphing. So looking at this, since we have a square here, we know that our x is never going to be negative because every single value we plug in is going to turn positive. So that's why we're getting those two square roots. We're centered at 0, 0, and we get one going this way and one going this way. We get two of them. And you can plug values in if you want. You got to remember that we are plugging in for y here. So you would plug in 0, and that would give you 0. And then we would plug in 1 and -1. But because of the square, the 1 and the -1 are going to give us the same thing. So we're getting those little bat wings here. A nice bat wing. And again, you can plug it in your calculator, which is what we're going to do to verify and make sure everything is correct. So for our x, we use t squared. For our y, we use t cubed. And then we hit graph. And there's our shape. So now all we have to do is see which way it's moving on this shape. We already know it's going to go from the bottom up. But let's just take a look at it. So let's start down at the bottom, like -2. And then we're going to move our way up. So -1 or 0. And it doesn't matter. You could even just say, you know what, I'm going to start with 0, 1, and 2. And look and see how it moves this direction, and then see how it moves on this one as well. So if we were to plug 0 in, our x would be 0, 1, and 4. And again, you can grab your table as well to look at this. So this is 0, 1, and 8. So we'd have 0, 0. I'm going to put them in red. 0, 0, 1, 1, 4, 8. So you can already see which way we are moving. So it is this is our direction. And our x value is going to be between 0 and infinity. And our y value is all real numbers, -infinity to +infinity. Now, you can also just go to your table and look at it that way. It will give us the value. So you can see that our y, since we are dealing with a y value going up, basically, right? We're plugging in the y values. We can see how the x's are related based from our graph. You can see that as we go from -3, we have a 9, -27, and then a 4, -8, and then a 1, -1. Our y value is moving up, right? Our x is coming in, and our y is going up. So if you plot those points, it tells you our direction. So there's our Cartesian equation. There is our graph with direction, and there are our x and y's. All right, let's do another one. All right, so we have x equals t plus 1 and y equals t minus 1. So just like before we start substituting, we really should look at our t. So on the first one, t plus 1 is greater than 0. And on the second one, t minus 1 is greater than or equal to 0. This means that t is greater than 1 and t is greater than -1. So we need to make sure that it's true for all t's. So if you just said it was the -1, that would include 0. If I plug 0 into the second equation, I get 0 minus 1. That's not real. This is what we need to use for our t values. So our first t to plug in would be 1, 2, and 3. And we should verify this with our calculator because you have this nice utility here. Oops, got to put the square root there. So second square root of t plus 1 and second square root of t minus 1. And we hit graph. And you can see that it's starting here. But if you remember, this is our x and our y. So what you really want to do is go to your table, and it'll tell you. You can see that we have errors up until -1 for the first one, but we have errors up until 1 for the second one. And so that's where it has to start. You can see they're both good here at t equals 1. That's where we're starting. So now if we were to plug it in, you can see we get our square root of 2 and 0. You might as well, right? It doesn't matter the order here. So if we plug in 1, we get 2. We plug in 2, we get 3. We plug in 3, we get 4, which is 2. And if we plug in 1, we get 0. 2 would be 1. And then 3 would be radical 2. So if you were to plot those, that's where that 1 square root, that's what our square root of 2, 0 was. So 1, 2 was right here. And then again, we're just looking at the x coordinates and y coordinates. So square root of 2 comma 0, square root of 3 comma 1, and 2 comma square root of 2. So it's 2 comma square root of 2. So right there. So you can see that is our motion. So we are moving in that direction. And so if I hit play, you can see there is our little Dalek moving up our line. So there's our graph for it. It's actually more upward than what I have in the picture, so we should change that. Actually, it's not that bad. So now what we need to do is make our Cartesian equation, and then I get our domain and range off of that. And so for the domain and range, we can actually see that our x is from radical 2 to infinity. So our x is greater than or equal to square root of 2, and our y is greater than or equal to 0, because our t is starting at 1, and both of them are increasing off to infinity. So now when we plug this in, the way I would do this is I want to have this as a y equals. So I'm going to take my t plus 1, square it to get rid of that radical, and then solve. Now, let me move these over actually. So we're just substituting. That's all we're doing here. So y equals square root t minus 1, and then we can plug that in. So y equals square root of x squared minus 1 minus 1. It's x squared minus 2. So there is our Cartesian equation. All right, so let's take a look at some more problems in the next video.